Hello, welcome back to the channel. If you're new here, I'm trying to learn C++ complete from ChatGPT. Right now I'm studying more about smart pointers. And yeah, it was actually a pretty good lesson I learned, is that I asked it to actually demonstrate how data structures such as linked lists would use pointers, smart pointers, and all of that. And one of the biggest examples was a linked list that I was able to construct myself with normal pointers. Was actually demonstrated with smart pointers, which I found pretty interesting because I thought smart pointers seemed a lot harder than raw pointers. Why would I ever use them? It actually said specifically that smart pointers are smart, so they're actually better for memory management and do a lot more stuff for you than having to actually manually delete stuff. So I feel like that's something I didn't really realize about smart pointers. I felt like they were always just this like really abstract thing that you do to, I don't know, make yourself look cool and optimal. But that does seem pretty important. But I'm still really not that good at my smart pointer syntax. I'm gonna tell it to review it for me. Okay, unique pointers are pretty simple because the whole point is that basically only one thing can have it at the same time, making it a lot more simpler than having sharing it and everything like that. So all I have to do is use my std make unique and declare it with like type std unique pointer. From there we can transfer ownership with std move. Boom. That is as simple as it gets. Now we have std shared pointer. In this, we can create a make shared. From there, share ownership by basically saying another pointer. And now, basically, both of them actually work. So I believe if I were to run this code and also wrote pointer2.show, we would also get my class show function. So I'm gonna test it out just to test my series. So right here, all we want to do is pointer2 show. Now let's test this out to see if my series is correct. And yeah, it works. Woohoo! I also noticed that when you reset the pointer, it says that pointer1 no longer owns the object. Does that mean pointer2 still owns the object? Though, so let's try that too. Okay, so this is what's happening, I guess. So first, we get the constructor from calling it. We can then share them. We don't actually have to call the constructor because they're sharing the same resource. They can both show it. We get the reference count. From that, we can call it again after the reset. Check that the reference count is only 1 because now only pointer2 has it. At the end of the program, finally, because it's out of scope, we can finally destroy it. Okay, that was a little complicated, but I feel like testing it out was actually a pretty good idea of mine. Finally, we get what I believe is like the weirdest of all of them, the weak pointer, which basically makes it so two objects can point to each other without a circular reference, if I can remember correctly. So in this case, my other class points to my class pointer as a shared pointer, and my other one uses a weak pointer to point back to the other one. You make both of them make shared. And from there, I can say the class pointer is my other class pointer that I've allocated. I think when I did this share pointer is now the other one. And now basically, they both reference each other and they can access each other. Explain how the classes could not be alive. Okay, when you call a walk method on a weak pointer, it returns a shared pointer that shares the ownership of the object if the object still exists. If the object has already been destroyed, because the shared ones have been reset or gone out of scope, walk returns. In this case, we're going to reset the other one that the first class has a weak reference to, and I guess after locking it, we can tell that it should not be alive afterwards. I feel like I'm getting this a little bit more, but now I'm going to go all the way back to the data type example I showed before and see if I can correctly understand the code. I honestly never understand what kind of a syntax this means. I'm gonna ask about that. Oh, I guess maybe what it means that while the other ones still exist, because you keep on moving to the next node, is that basically just a way to traverse to the end of the linked list? Yeah, okay, never mind. I just didn't read it all. So if I look at the class, that means it should be allocating next, or like declaring next as a shared pointer. But let me double check that. So yeah, I am correct about that. Okay, so like again, you don't really need your smart pointers. I feel like you could have done everything with normal pointers. Again, I guess it makes them more safe in some ways. Maybe in some ways my puny brain cannot yet understand. I feel like I've done quite a bit today. I think tomorrow I'm going to do more practice on assignments to really get this into my brain. Anyways, if you enjoyed this video, please give me a thumbs up. Hope you subscribe. Like always, bye-bye.